One, two, one, two, one, two, one, two, one, two. Woo! So hello guys and welcome back to this one. Today we are going to be looking at something interesting and it's going to be about binary trees. So we've gotten to our binary tree implementation, right? And that's the chapter 10, right? And our first question is to test if a binary tree is balanced, right? To see if a binary tree is balanced. But before we get into the solution or the problem, we need to understand what a balanced tree is, right? So we need to understand what that is. So there are other concepts around that. So there's a perfect tree, there's a full tree, and then there's a complete tree, right? But yeah, our focus right now is binary, and we are going to basically touch upon a bit of all these other guys and then see what the binary tree is, right? So basically a full tree is like a tree that has all its nodes filled. So the left and right nodes, everything is full to the brim, right? So it's fully occupied, right? And then our perfect tree is basically a tree where all leaves are at the same depth. So you don't have a depth lower than another, right? All leaves are on the same depth. So some might be missing, right? But so far they are on the same depth or the same line, you're good to go. And then you have a complete tree. Basically, it says every level is completely filled except maybe the last or like, so basically what it says is saying is that it is full from the left going to the right. So in a sense, let's say something like here. So we'll call this a full list, a complete list, right? Because we have it filled here, filled here. Then we see from the left going to the right. This is filled, this is filled. Now this guy is not filled, this guy is not filled. So we have this as a complete list. Now bringing us to what a balanced list is now. Now a balanced list is simply a list where it kind of defines from the node, right? So we have a particular node here, and what simply a balanced list is simply a list where the left depth and the right depth is not greater than the difference between the left depth and the right depth is not greater than 1. Simply. So if we have a depth, as we see here, we have a depth of 2 on the left hand side and a depth of 1 on the right hand side, the difference between these two guys is just 1, right? So that's cool. Basically meaning that, oh, we have values on a deeper level on the left side, right, as opposed to the right hand pointer, right? So basically that difference is just 1. So we could record this guy as balanced. That's from this node, from the perspective of this node, right? If we come to this node, if we're examining this node, just this node alone, we can still see that this guy is balanced because the depth of the left hand side and the depth of the right hand side is underneath 1. The difference between the two of them, rather, is underneath 1. This is 0 here. This is a depth of 0 here. This is depth of 0 here. This comes up to give you 1 and 1. That's if you're trying to get the height on the right and the height on the left, you get 1, and that's it, right? So we have that defined as a balanced. Now let's look at what an imbalanced is, right? Well, in what situation do we say that a tree is not balanced, or a node depth is not balanced in a sense, right? So we say that when the difference is greater than 1. So we look at this example here where we have depth going down deep. I don't think this is the greatest illustration of what's it called? A depth, a sorted binary tree, but just as an illustration, just to show how what imbalance is, right? We see that the depth on the left hand side is greater than uh the one on the right hand side by 1, right? So we see that the depth is 2 and the height is 0 here. When you do the subtraction or the difference, you find 2, which is greater than 1. And because of that reason, this tree right here is imbalanced, or this node right here is imbalanced. And then we have this guy as well. Now this guy right here is balanced because it's the left hand side and the right hand side return a height of 1, right? So this guy is balanced. just as this other guy and this other guy right here. So that's basically the idea. And then we are going to go on to see how we interpret this into code. But first, as we always do here, via brute force, and then we take it from there.